All right. Section 1.5, graphs of sine and cosine. So we've talked about different approaches to trigonometry. We talked about the unit circle approach where we defined sine to be the y value and cosine to be the x value of different points on the unit circle. We talked about the right triangle approach to trigonometry where we said some SOHCAHTOA. We could said that triangles um, could be used to create these trig ratios in a similar way that we created this unit circle. And now we're going to look at it at a slightly different way. And we're going to look at these angles as x values. So theta as an x value. And I kind of want to go in here and just kind of write theta, theta. Then we're going to look at them as if they were x values. And then we're going to graph um, the sine values with theta. So theta as x, sine values as y. And then we're going to try graphing cosine where theta is x and y is the cosine value of each of these. So we're going to go here. I'm going to go backwards on the unit circle. So we have backwards all the way to negative 2 pi. So if we started here, this would be negative pi over 2. So negative pi over 2. And then this guy would be negative pi. He's pi, but he's also negative pi. Pi over 2 is also negative 3 pi over 2. And this angle is both 2 pi, 0, and negative 2 pi. Okay, so sine values, those are going to be our y values on the unit circle. Y values on the unit circle. Now, I'm only going to be looking at, I'm going to erase these guys here. I'm only going to be looking at boom, 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 these like spokes, because we don't really need more than that to get a good idea of what the graph of sine and cosine look like. So let me highlight the y values. All right, so sine at negative 2 pi, the y value at negative 2 pi, the y value is 0. So on our graph, we'll have the point negative 2 pi comma 0. And I'm going to graph it just real quick, negative 2 pi 0, right there. Negative 3 pi over 2, it has a y value of 1. So sine is 1 at negative 3 pi over 2. We'll plot the point negative 3 pi over 2 comma 1. I'm going to mark 1 right here. I'm going to mark negative 1 down here. Negative 3 pi over 2 is at 1. All right. At negative pi, the y value is 0. At negative pi over 2, right here, the y value is negative 1. At 0, the y value is 0. At pi over 2, just like negative 3 pi over 2, the y value is 1. At pi, the y value is 0. At 3 pi over 2, the y value is negative 1. And at 2 pi, the y value is 0. So if I come down here and I plot that, let's see, I have negative 3 pi over 2. We have negative pi comma 0. So I'm just kind of looking at these points here. Negative pi comma 0. Negative pi over 2 comma negative 1. 0, 0. Pi over 2 comma 1. Pi comma 0. 3 pi over 2 comma negative 1. And 2 pi comma 0. So you get, depending on how good of an artist you are, of which I do not claim to be. I am not an artist, but there we go. He has a little wavy shape, which is cool, interesting. You may have heard of sine waves. That's what's going on there. Let's dig a little deeper. So now let's look at the cosine values. So those are the x values. So sine equals y val on unit circle. And cosine is equal to the x value on the unit circle. Again, we're really looking at these spokes because it gives us enough of a picture. You can see down here, I could have plotted some points in here at the pi/4s and stuff. It's just they're messy numbers and it's not super important. All right, at negative pi/2, the x value is negative pi/2. The x value is 1. So we have negative 2 pi comma 1. At negative 3 pi/2, the x value is 0. At negative pi, the x value is negative 1. At negative pi/2, the x value is 0. At 0, the x value is 1. At pi/2, the x value is 0. At pi, the x value is negative 1. At 3 pi/2, the x value is 0. And at 2 pi, the x value is 1. And we can plot these points. So we have negative 2 pi comma 1. Again, let me mark where I want 1 to be here. All right, so negative 2 pi comma 1. Negative 3 pi/2 comma 0. Negative pi comma negative 1. Negative pi/2 comma 0. 0 comma 1. Pi/2 comma 0. Pi comma negative 1. 3 pi/2 comma 0. And 2 pi comma 1. All right. And then you just pretend you're an artist. Oh, that was not a great one. And look at that. So right here, this is the graph of y equals sine x, and over here, this is the graph of y equals cosine x. And you might say, Professor Cook, I thought you said that the x value was for cosine and the y value is for sine. When I say y equals here, I'm using y equals as in the function sense. So I just as easily, instead of y, could have said like f of x. It's just a function that I'm naming y, f of x. Now here's the interesting thing. These look very similar, right? And indeed, if we come and bring this over here, they make the same shape. Cosine and sine make the same shape. Cosine begins right here. So it begins in a different place and they kind of go alongside each other, but they ultimately are the same graph. They just kind of oscillate between different values. So this is the base graph of sine, and this is the base graph of cosine, and we're going to do some transformations to these functions, and it's a pretty fun section. So in the next video, we'll talk about like the different things we can do to mess with these graphs, some properties of these graphs, and we'll go from there. So that's it for this video. I'll see you in the next one. Bye.